Good afternoon. Today's lecture, we're going to briefly go through the homework assignment and make sure that I answer any questions. The first one on part A says that you have a forecast demand of 23 units, 44 units, 27 units, 100, 90, and 100. So this is our gross our demand, and we want to get a net requirement. So I'm going to insert a table. And week 1, 2, 3, 4, 5, 6 weeks. And so the demand is 23, 44, 27, 40, 90, and 100. We have 10 units on hand, okay? But we're trying to maintain a safety stock of 5. Okay? And since we have 10 units on hand, but we're trying to maintain a safety stock of 5, what is our net requirement that first week? Is it 23?
18.
It'd be 18, right? Because we got to keep a safety stock of 5, but we already have 10 on hand. So it'd be 18, 44, 27, 40, 90, and 100. And so our safety stock would be at time 0. I probably should put a period 0 in here, so. Okay. $23, 18, 1. And at time 0, our safety stock was 10. Okay? So all we're showing is that you decrease the net requirements a little bit. Okay. Describe a bill of materials and provide an example of calculus of explosion, time phase, and multiplication. Well, a bill of materials is simply, and it could be a product structure or just in an Excel file, but it shows, in this case in a graphic form, the items that go into the end item and the lead times and the goes into quantity. So item A, to make one item A, I need 2 weeks to get 2 item Bs. And to make an item B, I need 1 week to get 1 C and 1 week to get a D. And then I join the B and the E to get the A. So I'm going to open Excel real quick. Come on. Okay. I am not going to open Excel really quick. Well, the computer has stopped working. So, let me go to the document camera. And here is, say, week 5. My requirement is 10. And then 6, it's 15, and 7, it's 20, okay? And that's my A requirement. What we do here, what's my B requirement? Okay. What's my B requirement? Well, I have to bring it back by the time phase, right? So I have to bring it back 2 weeks, but there's a goes into quantity of 2. So this becomes 20, 30, 40. And then I could ask, what's my C requirement? And sorry, I'm getting this messed up, but you have to bring C 1 week back from B. So 20, 30, 40. And then my D would be same thing, 20, 30, 40. And then my E, well, that takes 1 week from item A, and it's 1 for 1. So it would be 10, 15, 20. Okay? Painfully simple, right? All you have to do with calculus of explosion, take the item, bring it back in time for the lead time, and multiply by the goes into quantity. Make sense to everybody? And it's real easy when you have one item. When does this get hard? When you have thousands of items, right? Let's say I'm assembling an ambulance. There might be 10,000 items. So if I need 3 ambulances 8 months, 5 months from now, I may have to start ordering the parts in a month or 2 to assemble that final component. Does that make sense to everybody? And the trick is, the calculus of explosions is one thing, but what else do you have to do? You have to account for setup cost, and then pool orders together, and that's the MRP with setup cost. And capacity constraints, obviously. So the next one, lot sizing, which is starting to get into setup cost with a forecast demand. You have the following requirements: 10, 22, 40, 10, 20, 100. Your setup cost, K, is 200. Your holding cost is 1. And we want to do this using least unit cost, part period balancing, and silver meal. So we're trying to get a production schedule for that requirement. Lot for lot, what do I do? Lot for lot means produce in every period there's demand. So my lot for lot production would be what? 10, 22, 40, 10, 20, 100. How much is that schedule going to cost? Do you carry any inventory? No. So your only cost is what? Setup. Each setup costs $200. So it'd be 200 times 1, 2, 3, 4, 5, 6, or $1,200. So lot for lot, $200 what? Dollars per setup and 12 setups. Now, let's solve it with silver meal. And that's trying to minimize the average cost per period of holding and setup divided by the number of periods. And do that till it increases. So, let's compute that cost, which is holding plus setup over number of periods. So if we just set up for the first period, what the holding would be 0, and the setup cost would be 200, divided by 1 is 200. If we produce in period 1 for periods 1 and 2, the holding would be what? 22 times 1 plus 200 divided by 2, which is 111. If we do for 3 periods, it would be, well, we'd have to hold for 2 periods. So it would be 2 times 40 plus 22 times 1 plus 200 divided by 3. And $80 plus 22 plus 200, and all that divided by 3. Wow, it's still going down, because that's 166. So K4 would be, now we got to hold it out to there, 3 times 10 plus 2 times 40 plus 22 times 1 plus 200 divided by 4. $83. And then K5 would be all that junk there. And then you would do 4 times 20 plus all that junk divided by 5. $82.4. And then K6, which would be produced for everything, would be all that junk plus 100 times 5 divided by 6. And now the costs start increasing, because that would be 152. So my silver meal schedule would be to produce in time period 1 for all those periods. So 10 plus 22 would be 32 plus 40. Let's get this right. 10 plus 22 plus 40 plus 10 plus 20. So I'm going to, oh, what did I do wrong there? 40. So I'm going to produce 102 items in the first period, and then 0, 0, 0, 0, 100. That's my final schedule. What's my inventory look like? Well, produced 102, used 10, so I'm left with 92. Subtract out 22, I'm left with 72. Subtract out 40, I'm left with 70. Subtract out 40, I'm left with 30, 20, and 0. And 0. Okay, so what's my setup cost here? Well, my setup cost is 2 times 1,200, or 2 times 200, which is $400. My holding is $1 per unit, so that I hold, so it would be 92 plus 70 plus 30 plus 20 times the $1 per week. It's did I get all those? $2.11, $2.12. So my total cost is 400 plus 212, which is what? $612. Okay? So Initially, I went lot for lot, produced in every period, right? But that was inefficient because I was paying that $200 setup cost as opposed to $1 per unit to hold it each week. I did the silver meal heuristic, came up with I should produce in the first period and the last period, and a total cost of $612, which was half of it. Least unit cost, instead of dividing by the number of periods, you just divide by the number of units produced, and you may get a different answer. So make sure to do those and submit them with your homework. Understand them. There might be a simple question on the test about them. What is the primary difference between EOQ ordering and lot sizing based on least unit cost or anything else? EOQ assumes what? Constant demand. This assumes demand's based on a pattern that you know. It's deterministic, but look, requirements go 10, 22, 40, 20, 100, okay? Makes sense. When you use EOQ, straight constant demand versus a constant demand that varies with time period.
So EOQ is a total?
Constant.
Okay.
Doesn't change. Okay. Question 3 asks to schedule the following jobs, first come, first serve, EDD, shortest processing time, first. So I'm going to open Excel because this becomes really easy in Excel, hopefully. Oh, come on. Copy, paste. Why does it not? Okay, this is embarrassing. Let's try to copy one column. Okay. Now let's just retype it. So, 1, 2, 3, 4, 5. The due dates are 22, 14, 19,
55, 80.
55, and 80. And then the processing times are 15, 25,
8, 3, and 30.
8, 3, and 30. Thank you. Okay. Now, we want to schedule these jobs, and let me get it so you guys can actually see it. Okay, if I want to put these jobs in first come, first serve, well, they're now in first come, first serve order. That's an easy one. So when's the completion time? Well, this one would complete at time 15. This one would complete at 15 plus 25, and so on, right? Because you take the time it starts, add the processing time, you get the completion time. What is the tardiness? Well, it would be the maximum of the due date, the completion time minus the due date, and 0, right? That job's not late, but this next job completes at time 40 and was due at time 14, so it's 26 units late. And that's 29, and then the last one's 1 unit late. So what is the average tardiness? Well, tardiness would be just average. 11.2 for first come, first serve. What's the average flow time? Well, that'd be just the average of the completion times. And then number of late jobs would be 3. So that's first come, first serve. Now if I wanted to do EDD, Okay, doesn't allow any copying and pasting. Okay, now I would just sort by due date. Data, sort. Oh, come on. Okay, now I have my new schedule. I can compute the completion times, the tardiness, the average flow time, and the number of late jobs just by pasting. And we can see that y maximum of due date. Okay, so now I have 4 late jobs. Tardiness went down a little bit, etc. You get the idea, right? So finish that section. Okay, next problem. You have 3 parts in series. The reliability is 95, 99, and 97. What is the system reliability? If you have parts in series, it means what? It fails if one of them fails, correct? So if they're in series, you multiply the failures or the reliability? You multiply the reliability, right? Because they all have to survive for the whole thing to survive. So R series equals R1 times R2 times R3. Now, if they're in parallel, you would multiply the failures because they would all have to fail for it to fail. Make sense? So that's 0.95 times 0.99 times 0.97. And anybody got a calculator?
Yes.
.97, 91% reliable over the 3-year time. Okay? Real simple. Now remember, we talked about in class how if you have a complex system of parallel and series, you can use fault tree reliability to replace this series component with an identical component with a similar reliability, right? Or if you remember, we worked a fairly complex structure just by breaking it down, just like you'd work a circuit in electrical. Yeah.
So in parallel, it's going to be 1 minus...
The reliability all multiplied together.
Okay.
Like if you had this situation, two 99% reliable components in parallel, well, the system would then be failure parallel equals failure 1 times failure 2, right? So that'd be 0.01 times 0.01, which would be what? 0.0001? Right? So the failure in parallel would be 0.001, so the reliability would be, right? So adding more components in parallel, you can put on as many 9s as you want. Make sense? Okay. This is an important question. Why would experimental data for reliability be censored? What's the issue with that? Censored means you can't run the experiment long enough, correct? So reliability data is going to be censored because let's say I design a new aircraft engine. That aircraft engine is going to run for maybe 30 years. Can I set up an experiment that runs for 30 years on thousands of engines? No. So your experiment length often is shorter than the expected life of the item. How can you deal with that? Well, you can come up with a model and test a lot of them. And that's how you do it with semiconductors. Or you could come up with a physical model and test them under accelerated conditions, which is what you would do with a car or maybe a aircraft engine. For Part C, for graduate students only, you have a part composed of 3 components in series. Just do the distribution for the exponential, you multiply it together, and you'll come up with an expression in terms of the exponential distribution and can simplify it. What is the Weibull distribution? And then finally, I want you guys to write a half a page about lean manufacturing, Six Sigma, just-in-time, quick response manufacturing, predictive maintenance, and preventative maintenance. Okay, so that concludes the discussion of the homework. Undergraduates, I guess, can log off at this point. Stay on. The rest of the discussion is going to be quick. The final exam will be posted online as soon as I get around to it, definitely by Monday. Do not cheat, obviously, on the final. That will get you in so much trouble with the department. If you're a graduate student or an undergraduate, it's not worth it. Exam's going to be curved, so if you help your friend, you may be getting a B instead of an A when they do better than you overall in the course. So that's 2 reasons to not do it. And then the final thing is that graduate students' exam is going to be 4 hours, open book, open note, online, and there's going to be a series of essay questions. And I want you guys to answer the question in terms of a business case. So it could be something like, the question could be, let's say, quick response manufacturing. And I want you to step by step go through and put down what questions you would ask, how you would respond to the situation, what data you would require, how you would solve the problem. So if it says case study, I'm not asking you to solve the problem. I'm asking you to give me a detailed explanation of how you would attack the problem and solve it. Does that make sense to everybody? So, graduate students, there's going to be a pool of about 15 case study questions. So no 2 students will get the same case study questions probably. And then you'll have the same pool as undergraduates for your test. So half multiple choice, half case study. So pick 4 hours sometime between now and the final exam and just take it, okay? Try to get it done. Obviously, the exams have to be submitted before this class would have a final exam. Okay? Does that make sense to everybody? So the test will be posted, and that concludes the class. I hope you guys have enjoyed it. Enjoy your Monday will be a question and answer session in class. I will be here, but I'm not expecting any students, so I'll have nothing prepared. But if you want to come ask questions, you're more than free to. Okay? And, academic honesty on take-home exams is critical. It causes lots of problems for the students, and, it's bad for everybody involved. So, good luck with your exams and your course. This gives you a little flexibility, right? So that you can finish up some of the other stuff for your other courses. So design it however you want to design it to get everything done, okay? Have a great day, and I want to say you guys have been a great class. I enjoy teaching this class. I hope my love of the topic has come through. This is truly exciting. And to conclude, one of our students went online, and there's a free Apex iPad iPhone. On both. So you can download a study guide for Apex that's free that has a bunch of cards and vocabulary words. And it was basically like what I said, right? A bunch of vocabulary words that are similar to the vocabulary that we learned in this course, just slightly more industry specific. And, it's probably a good thing to consider as you move forward in your career if you're doing supply chain management to consider Apex. Have a great day.